So, still not satisfied. They're like, we need some more technologies. We're going to figure this out further. They came up with a quadrant, astrolabe, cross staff, and telescope. You're actually going to build your own astrolabe later, and I'm going to get you to do something with it. Telescope, should be familiar with. Cross staff, basically for determining angles between 2 points. And quadrant is going to tell you like kind of where in the sky you're looking at. Next thing we needed to talk about was astronomical units and light years. When you want to go to, let's say, Edmonton for the weekend, it would not make sense to measure the distance to Edmonton in millimeters, because it would be like such a big number that you wouldn't even know what to do with it. Same thing with space. If we want to measure the distance from, let's say, the sun to Saturn, doesn't make sense to measure that in kilometers because it's a huge number. What we do instead is we define a totally new unit. And we say, okay, AU, that is our new unit, means astronomical unit, and it's about 150 million kilometers. And now, every time we have 150 million kilometers, we get to call that 1. So if we had 300 million kilometers, we would get to call that 2 astronomical units. And basically what that does is it gets our numbers to be a bit more reasonable to work with. Sometimes that's still not very helpful though, like if we're going outside of our solar system, because you would have the same problem. You would be measuring, like if you're measuring to another solar system somewhere way far away, it would be a huge number of astronomical units that doesn't really make sense. So that's where light years come from. Those are even bigger. And what that means, like light goes pretty quick. It's like 300 million meters per second. 1 light year is how far light can travel when it's going 300 million meters per second. How far can it travel in a complete year? So it's a really, really big distance. Okay, so yeah, we use light years between galaxies. Sorry, I said 3 million, it's 300,000-ish. But at any rate, light years mean a really, really big distance. Okay, I'm actually going to skip over this part for right now. We'll come back to this later. For right now, I want to talk about constellations. So if you've ever looked up into the sky and been like, oh look, there's the Big Dipper. That's a constellation. False. Big Dipper is not actually a constellation. What is a constellation is Ursa Major. And Ursa Major was the bear. And so we talk about like some of the legends and cultural aspects of the stars. When people used to look up and see these stars right here, looking at the picture on the left, when people used to look up and see that, they went, oh, that looks like a bear. And then they had some kind of story to tell about why the bear is there, what the bear does. If you follow those stars, it's like the bear is guiding you, so how is the bear going to guide you? Those kinds of things. The Big Dipper is, if you look just at the top left corner of the bear, it's the tail, and then the 4 stars that the bear is connected to, or that the tail is connected to. That is called an asterism. It's not an actual constellation. There's 88 actual constellations, and there's tons of asterisms. So asterisms are the smaller groups that we kind of recognize, but they're not officially constellations. So we talked about like using stars to navigate. If you're going to do that, you need to be able to tell, okay, where actually is this star? And so we have 2 different measurements that we take. The first one is called azimuth. And what you do is you face north, and then you rotate clockwise until you are pointing at the star. And so if there's 360 degrees in a full circle, let's say you did half of a circle, that would be 180 degrees. If you only did like 1/8 of a circle, that would be 45 degrees. So depending on how far you rotate, that's going to tell you how many degrees you've gone. We call that number azimuth. When you are there, so once you've rotated from north to your star, the other thing you need to do is figure out, okay, is this star really low on the horizon, or is it higher up? Is it somewhere in between? That number is called zenith. And so what you do is you start totally flat, and then you measure up until you get there. And so whatever angle that works out to be, that is your zenith angle. So you are actually going to make an astrolabe. And I've got these things, the protractors for you in a Word doc. You can print them out there. Hopefully you have these things at home. If not, you can try to improvise. Doesn't have to be perfect, it just has to work. So first thing, cut out your protractor. Then, if you have a paper plate, glue it onto there. If not, it'll be okay without. You're going to want to mark on, no, that's what the protractor is for. Never mind. So you've got these all on your paper plate. If you didn't have a paper plate, just the protractor. Then cut out just the 90-degree protractor. You're going to take that and put it on the other side of the plate, or glue it just onto the back of the protractor, but make sure you line up the center. That part's important. Then you want to take a straw and you want to put it, how it's shown in this picture here, on that protractor. You want to put a small hole through the middle so you can get a string through there. Tape it to the other side so it doesn't fall off. And then we need some kind of weight to hold this down. So you can use a washer, you could use like a quarter, whatever works. If we want to find azimuth, so remember, azimuth is the one where you are starting at north and you're rotating until you find your star. What you're going to do is you are going to point north, or 0 degrees, on your protractor at the North Star. And then you are not going to turn your astrolabe. You're going to keep your astrolabe pointed so that north is at the North Star. What you do then is you look at the constellation you're trying to find. And so you're going to keep holding your astrolabe pointed the same direction, but then look at, okay, my star, if I were to follow that into this protractor, which angle does that line up with? Write that number down. To find, oh, I didn't give you the instructions for zenith. To find zenith, this is the one where you're like, how high up off of the ground or off of the horizon is it? Now it's okay to move your astrolabe. You're going to look at your star through that straw. And what's going to happen is the string is going to fall somewhere between 0 and 90 degrees. So start with it so that your string is at 0 and you're looking totally flat outwards. And then as you rotate it up, the angle on your astrolabe should change. So make sure you're starting at 0, it's going up towards 90, and then you should be able to read your zenith calculation off of that. Okay, this is like a super brief summary. Basically just tells you the topics that we covered. We didn't do protoplanet hypothesis or life cycle of sun, so don't worry about those two. But the other ones, you should be able to go on your study guides.